I gotta make sure that we're thinking about this stuff in the right way. I know it's easy when you're looking at lots of relatively hard algebra like this to just get focused on the nitty gritty. I mean, how do you just, how do I get an answer? How do I do the factoring? But don't lose sight. Chapter 5 is a big picture chapter. At the end of the chapter, I'm going to give you a big test that just has a bunch of quadratic equations that you have to solve, and there's about 5 different ways to do it. You got to pick the right one. We only have 2 right now, so that's good. But we got to make sure we get the right one of the 2. So what about a problem like this? If I'm going to solve this equation, and it's an equation, I have an equal sign there, right? So I want to find the solutions, the values of x that satisfy this equation. What is my strategy?
Isolate it.
Okay, when I can, I'm going to isolate x. Now, I'll ask you that again in a second. Okay, good. So what's the very first thing I want to do here, though? Get it all on one side. Good. Okay, I want to get it all on one side. And I haven't, I've said this stuff, but you haven't probably seen a pressing need for this yet. You will. So I'm going to say it again. Even though it'll work both ways, you definitely want to have a positive value of a, right? You want to have a positive leading coefficient. So that dictates which side of the equation we're going to push things towards. So left or right? They got to go left because we need the a to be positive, right? So if I push them left, I'm going to get what? 36 x squared minus 25x plus 4 equals 0. Now the equals 0 is important. We got to get it in standard form, equal to 0. Okay, so now is Ms. Broad, what's our strategy now? Are we gonna isolate or factor? We're gonna factor, aren't we? We can't isolate here. How come?
Because there's 2 x's.
Because there's 2 x's, right? See the difference now? We're stuck with 2 different x's, so we can't isolate. Occasionally I see people, they're getting a lot better at this, but still sometimes people want to try to, they want to try to get that, maybe this x by itself. So they'll start to push stuff over to the other side of the equation, or they'll subtract 4. Don't want to do that. We don't want to pollute the 0. We want this equal to 0 because ultimately our goal, remember, is to write this in factored form like that, right?
Yeah.
And in order to make that work, we have to use our zero product property trick. Our strategy is take one big nasty equation and break it up into 2 small equations, 2 small factors that I'll set equal to 0. So I get 2, when I set this one equal to 0 and this one equal to 0, those are easy, small equations, right? Finding those zeros is easy. They're going to end up being linear equations, piece of cake. This is hard, right? So now the process of getting there. Okay, talk to me about this. What's the first thing we want to try? Okay, that's what we're going to do, and probably the reason you're saying that is you've already tried this in your head, but what do we want to try even before we jump into that?
If there's any multiply.
Good. Yeah, you guys all get that? Okay, so to paraphrase, we always want to see if we can kick out a greatest common factor to make this thing easier. Is there a greatest common factor?
No.
There's not. There is no number that divides into all 3 of those, and this has no variable. So I can't factor out a variable because it doesn't exist in one term, right?
Yeah.
So we're stuck. We're stuck with the a times c, then split b. The possible alternative would be trial and error, but not a good idea here. 36 has a whole bunch of factors, right?
Yeah.
And 4 has some factors too. So that's not a good idea. We want to just go ahead and resign ourselves to the fact we got to do a times c, then split b. It's not fun, but it's our only choice here. So what is a times c?
144.
144 because a is 36 and c is 4, right? Okay, so now we're looking for magic numbers, but let's try to let's narrow down our search. If they're going to multiply to 144 and add to what number? Negative 25. What 2 negatives? Good. We know they both have to be the same sign and they both have to be negative. That helps, right?
Yeah.
So we want to find numbers that multiply. We know the signs are negative. We want numbers that multiply to 144 and add to 25. And then we know they're both negative, right? Now remember the patterns we have with this. There's some helpful patterns. remember that the more disparate the numbers are, the further they are apart, the bigger the sum. For example, if we took 144 and 1, that's a huge sum. That's not going to fit, right?
No.
The closer they get together, the smaller the sum. Okay? So for example, well, kick some out. What if we tried, what's probably the most obvious
12 times
12 and 12? So what if we split this into negative 12 and negative 12? Those add to negative 24. Well, that's almost it, isn't it?
Doesn't work.
Almost it. But it's a little bit too small, so that means we need to get numbers that are a little bit further apart, but like one tick apart. We want to get the next factors, probably, if any of them work at all.
13.
So 13 doesn't go into 144, 14 doesn't, 15 doesn't.
11
No, it goes into 144.
11.
What is it?
11 and 14.
No, 11,
I
that's,
tried it.
doesn't work.
13, I can't do it.
11 and 14 is 150.
Just had to get through that one.
No.
15 is not going to work. What about 16?
16. Let's go with
16 's gonna work.
16 times what?
9.
9. Aha.
What?
Okay, right? And that works, doesn't it?
Yeah.
Because negative 9 and negative 16 is negative 25. So we found the magic numbers. These are the winners.
Winner, winner.
So that tells us, they tell us how we're going to split the middle term, right? Now, don't confuse. I think sometimes people confuse these with somehow with like the answers or something. That's not it. We're not there. That just tells us how to break this into two groups of two, right? So now,
I wish those were there.
so there's our template, right? I'm losing some people's focus here.
36x squared minus 12. 9. 9 out.
Okay. So the contents.
And then
So the contents of the first group would just be the 36x squared,
and negative 9. Minus 9. Minus 9.
Yeah. and either minus 9x or minus 16x. Doesn't matter. We'll just do minus 9x. How about
It
that?
works better.
So then if that's the minus 9x, that means the minus 16x goes there. Good. Okay, good. All right, so now we've got this thing split into two groups. Now we know that the pattern is going to be, and we know it's going to work, right? If we can find magic numbers, you're guaranteed that A times C then split B will work.
And they're
Yeah, I'm gonna wait for, I gotta wait for everybody to do it.
And is there always that solution will always work on every single?
If, one more time, if you can find magic numbers that multiply to AC and add to B, this will always work.
Awesome.
If
Is
you
there
can't,
any that
okay,
will
and the other nice thing about it is, if you can't find magic numbers, don't bother, it won't factor.
Okay, with the answers. So that will always work. with
Okay, so
the-
then the answer would be,
No solution.
no, but we just don't know how to do it yet.
Oh, okay.
If we're trying to solve this equation, we are gonna have some other techniques for doing that real soon. But for now, if it doesn't factor, that's one strategy that's out the window and we don't have a replacement yet, okay? But we will. All right, so we know this is gonna work, so then we know the pattern is gonna be this. We know that each of the two groups has to give us a greatest common factor and a leftover, right? And we even know how this pattern, we even know some stuff beyond that. Okay, we know that whatever the leftover is from the first group, what about it? What's important?
It's going in the second.
It's going to the second group, right? Okay, so now we can just focus our attention on the first group. Okay, what is the greatest common factor of the first group? Okay, so 9's the number part. And what's the biggest value of x we can divide away? X to the 1. Good. Okay, so we get, does that make sense?
Yeah.
Okay? Right? Because remember our rule, when we're factoring out a greatest common factor, we always want to take out the biggest possible power of x, which is always going to be the power of x in the wimpiest term. So that only has one x to give away, so that's all we can take, right? What's left over then?
4x minus 1.
Okay, so we immediately know that goes over there.
Yeah.
Okay, and then now the question is just, what do I have to distribute to get group 2?
Negative 4.
Okay, good. So now we're done, essentially. We just have to break that into two factors. So there's one more step.
And then find the 0.
Right. Right. So one more step to the factoring. Okay, so now we know that we've got two groups. We just want to undistribute from each group our common factor, which is the blue factor, right? So if I undistribute this, meaning factor it out, what's left behind? If I undistribute the 4x minus 1 from group 1, I'm left with the 9x. Undistribute it from group 2, I get plus negative 4, which is a minus 4, right?
People are smart when they do something.
Yeah.
Equal 0.
Equals 0. Okay, and so now the last step is just to find the zeros of the individual factors. So these are simple equations to solve. There is a, oh, something is burning.
I think it was Miss Wilson's mom.
Oh, okay, yeah, all right.
She can't make popcorn.
All right. There'll be, I think we're okay. I mean, if it's, I think we're fine. Okay, anyway, back to business. Okay, so now here's the other thing. Okay, here's the other thing I see happening sometimes. Sometimes people then want to say that the zeros are 1 and 4.
No.
Okay, but it's not.
done
right?
yet.
We have to set the whole factor equal to 0 and solve. So now you can do this part in your head, but if I set the equation if I set the expression 4x minus 1 equal to 0, what would be the two steps to isolate the x?
Last one, divide by 4.
Add 1, divide by 4, right? So what's my 0?
1 fourth.
Okay, or what about over here, the 2? Okay.
4, 9.
You're a little late.
Sorry.
So those are the answers. Separate them with a comma, right? Okay, this process right here, you can, if you want to, you can write this out, but I would encourage you to move away from that when you're comfortable. I mean, we could, for example,
I write it out, yeah.
okay, so let's look at the red one. If I set 9x minus 4 equal to 0, I'm just solving for x. So I add 4 and divide by 9. Oops. Right? Okay, and so really you can always just, you can just look at these and say, okay, imagine a 0 over there. I'm just going to add the 4 and divide by 9. Right? You can do that in your head. Okay, questions on that?
No.
So far so good. All right. Okay, so now what about one like this?
Wait.
Back?
Minus 12. What's the answer?
So the answer is
4, 9,
1
2, 1,
fourth,
4.
comma, 4,
those
9.
two. Those are my solutions.
No, okay, I'm.
Okay, so the question would have said, find the zeros. I don't think I have a question up there, but it would have said, okay, it's solved.
Oh, never mind.
Right.
I
Okay. And then it would have said if there are multiple solutions, separate them with a comma. Okay? All right, so what about one like this? What's our strategy here?
Minus,
To
isolate.
isolate x.
Good, isolate x. Okay, here's what we don't want to do, and here's what I'm seeing a little bit. I'm seeing this both correctly and incorrectly, but either way, you don't want to do it. There's a tendency sometimes for people to say, okay, well, let's just go ahead and expand this all out and make it a problem like the last one. Not a good idea. Okay, so because we can point to a single x, we can isolate it. Now let's rehearse the operations, because it's not hard. In order, what are the steps we would take to get that x by itself? Okay, so step 1, subtract 22,
Divide by 2.
divide by 2, square root,
Minus 7.
-7,
Divide by 8.
divide by 8, and we're done.
And we're
Right?
done.
Okay, good. Okay.
Oh,
okay. Say it again.
That's not perfect.
It's not. You're right.
Make sure that there's less and it's like plus or minus.
Right. But even if it were a perfect square, you'd still have to put the plus or minus there because we're square rooting both sides. So let's go through the steps on this one. Okay, so first step, you said subtract 22, right?
350.
350.
Hey, I got this one on my test. I mean, on my.
This exact oh, this is yours.
Yeah.
I did take this off yours, yeah.
I was gonna say, I remember this one.
Okay, now what?
Already took it away.
Divide by 2.
Divide by 2.
I think so, yeah. And And now you
Okay.
square. Do the square root.
Okay, good.
Square root.
Okay, so now a couple things here. This is an important step. When we square root, we can combine some things to make this easier.
Yeah.
So when we square root on the left, we're left with what?
Just 8x plus 7.
Okay, do we need the parentheses?
No.
No, we needed them here because it's a quantity being squared, but once we've undone that, they don't serve any purpose, right?
C.
So we get 8x plus 7 equals
Square root of
plus or minus
Square root of 175.
square root of 175.
Which
Okay,
you
Five
could
or
make
seven.
it stop.
ah, good. Okay, so is there a perfect square in 175? Yeah,
Yes.
25 times 7, right?
Yeah.
Okay? So if it's 25 times 7, square root of 25 is 5, square root of 7 is square root of 7.
So it would be 5 square root. How do you do that in your head?
What I just said. Oh. Ew.
I know the square root of 200.
What is it?
10 and then the
Okay,
square
question.
root of 2.
How did we get that?
Why are you square rooting?
Because here's what we did. We square rooted both sides to cancel that, right?
You can't like put 8x plus 7 and then 8x plus 7.
That thing right here.
That would make it long.
You mean expand it out? Well, we could, but now think if we do that. If we expand out the 8x plus 7 squared,
Let's not do that.
look what we're going to get. We're going to get 64x squared plus 112x plus 49 equals 175. We got to combine like terms. We got to do a times c then split b. That's not fun, right? That's going to be much harder, right? Does everybody see that?
Yeah.
It would work. Okay, it would work, but it would just be a lot of extra steps and a lot of extra room for making a mistake. Okay? So here we get the plus or minus. Okay, now from here you have a choice. If you really want to, you can break this up into two separate equations and solve them individually. Those two equations would just be 8x plus 7 equals 5 times the square root of 7, or separately, 8x plus 7 equals minus
But don't you
5
have to do that
square
on
root
the
of 7.
middle anyway?
Right. Now, either way, you're going to end up doing the same algebra steps twice, right? So if that's, I mean, if you really want to, you can, but here's what I recommend. If you just think of, there's one little trick here, and I've said this before, but this is a good one. You can combine the algebra for both equations into one process, right? What are the two steps in order for getting the x by itself here?
Minus
First,
7.
okay.
Subtracting.
So subtract 7, divide by 8. Now subtracting 7 is the very same thing as adding negative 7.
Put it to the left.
Good, so as long as, if you're adding or subtracting something from both sides, as long as you put the number in front of the plus or minus, it's really easy to get the answer out of this, both answers. So we end up then with 8x
Equals.
negative 7, good, plus or minus.
5 square root of 7.
Okay, now here's the other thing where people were having a little issue, so watch this very closely, please. What's the last step?
Divide by 8.
Divide
Okay,
by 8.
divide by 8. Now let me say a few things about that.
Underneath.
The whole thing.
And then if it can simplify, but usually that one you can't. That one.
Good, okay. So that cancels the 8s from the left side because they're common factors, right? On the right side, that 8 is now a common denominator. Okay, do you see why?
Yes.
Okay, because there's a couple of things we need to recognize about this. Because I've got a plus or a minus sign on the top, I've got two separate terms divided by a single denominator. That's the definition of a common denominator, right? Okay, can I combine those terms on the top?
No.
You can't. Some people have tried to do that though, and I it's okay. I mean, that's just an old, that's old Algebra 1 stuff that maybe it's just we're a little rusty. Let's look at that for a second and make sure everyone understands why. If I had something like, say, negative 7 plus 5x, everybody knows we can't combine those in here because they're not like terms.
No.
Why are they not like terms? They're not like terms because, because the 5 is multiplied by another factor. The factor happens to be a variable, but it's just another factor that this one is not multiplied by, right?
Yeah.
Okay, well, it doesn't make any difference if that's an x or if it's a square root of 7. It's still a factor that the 5 is being multiplied by and the negative 7 is not. And so therefore they do not combine, right?
Yeah.
Okay. So I'm stuck with those the way they are. Now I can write my answers. I can't write it that way. I have to separate them. If you look at the instructions, they say you have to separate them with commas. And so all I would have to do then is just write one of them with the plus sign. So I get -7 plus 5 times the square root of 7 over 8, and that's fine. You don't have to separate this into two different terms. You can leave it in terms of a common denominator. It's a good way to do it, actually. But either way would it accept. Comma, -7 minus 5 times the square root of 7 over 8.
So
Can that be, go ahead.
that's our answer.
Yeah, can that be simplified?
No.
No, it can't be.
I have a question.
Yes.
When it is simplified, let's say like 5 on the bottom,
Mhm.
and then the 5 on top turns into a 1, would you put the 1, or would you
No.
put it?
Okay, good question. So what if, let's do a what if here. What if this was instead, let's just take this guy right here, for example. What if this was -7 plus 5 times the square root of 7 over 5? The question is that simplified? Well, yes and no. If you leave it like that, it is simplified. If you write it in terms of a common denominator, it's simplified because 5 is not a factor of -7, right? Does that make sense?
Yeah.
Okay, now if I split it into two separate terms, right, so I break apart the common denominator into a denominator that goes with the first term and the second term, I would get -7/5, which you can't simplify, plus, and I could even combine it into the plus or minus if I want to. If I'm doing both of them. Yeah, 5 times the square root of 7 over 5. Well, those 5s do cancel, don't they?
Yeah.
Right? And
How
so
would that
if
be
I
what?
break it apart, then I would have to reduce this term, because that wouldn't be simplified. So I'd have to write it as -7/5 plus or minus the square root of 7, right? But if I choose to leave it as a common denominator, that would be fine. Okay?
You don't have to simplify.
You see the
say
difference?
If it was the 5 on the bottom instead of the 8.
If it was a 5 on the bottom, if you leave it as a common denominator, you can't go any further because I can't cancel any part of the 5 with the 7.
So the answer is -7 plus, plus 5.
Plus, exactly, plus 5 root 7, all over 5 is fine. If I split it apart though, I would have to cancel those 5s in the second term. Just, I mean, it's not a huge issue, but you see how you see the difference there? Okay, what about something like that?
Well, then, you do it all.
You can
It
get all
turns
of
into
it.
a -1.
-1
Square root of 7,
plus.
or plus.
Okay,
or
good.
minus.
Yeah, okay, good. Now I know this might seem like overkill, but I've seen a number of people having trouble with this kind of issue. So I want to there's two ways we can look at this. And I think this is where you get good at algebra, is by seeing how all the roots converge in the same answer. Okay, let's call this is going to be the purple method. And the purple method would be if I split it into separate parts, I break apart the common denominator, I get -5 over 5 plus or minus 5 root 7 over 5. Well, both of those can be individually reduced, right? -5 over 5 ends up being -1 plus or minus the square root of 7. So that would be my simplified answer, right? Yes, ma'am.
escape all that by going with the first
Okay, but even if I go with the first one, now this is a little different. So if we look at our orange,
Oh, but you can't simplify that one.
I can, you're right. So if I leave it as a common denominator, notice that 5 is a common factor of the top and the bottom, isn't it? In other words, I could factor out or undistribute a 5 from the top. Okay, now I want you to see this. This is if you get this, watch this closely, because this will clear up any misconceptions you have about when you can cancel and when you can't. So if I factor a 5 out of the top, what's left behind?
-1 and or 7.
Okay, so now on the bottom, I've got a 5. Now, why is it that I can cancel those, but I couldn't, for example, on this page, down here, but I couldn't cancel those. That's a no-no. Can't do that, right?
Because it's being distributed.
Yeah, I can't cancel these because the 5 on the top is not a common factor. Does that make sense?
Yes.
The 5 square root of 7 is being added to something, right? See the difference? Okay, over here, this 5 is being multiplied by another factor. So because the 5 is being multiplied by stuff and not added, it is a factor and not a term. I can only cancel like factors, right? So these now I could do away with, and that just gives me the same answer, doesn't it? Okay? See how that works?
Yeah.
Okay. All right.
Yes.
The lab.
Okay, I'd be willing to do that. So now we're stuck with the crappy 249 lab. This ought to get you going on this stuff a little bit. I'm putting these assignments, I'm putting due dates on these assignments, and I'm putting them in the book, so you got to get kind of caught up. I won't do anything new today. I was going to.
Any help?
Okay, 249.
I'll admit,